Hey, this is Steven from Legit Tech Tutorials and the Green Engineers, and welcome back to my video on the DIY metal mill. So today we are going to be talking. Sorry, I'm looking at which episode we are on. DIY metal mill. It should be 12. Yeah, so we're on episode 12. So in last video, it was pretty exciting. We finished with the was it a green milling machine? We finished with the XY custom layout. ZY custom layout. And now we are up in the range of, I think it was 300 pounds or so. Here, move out of the way. My cat, she has no clue what she's trying to do. 4601 divided by 16. So about 300 pounds. So that's good, and obviously that's without the ball screw. I'm going to say ball screws are easily another 20 pounds. So we're up in the 300 pound range. Target is 800 to 1,000 pounds. I think that will be pretty good. So right now this, I think, is way sturdier than what you would get on a Tormach. Completely custom, very easy to do on a manual machine, except for this over here in this corner here. This is not as easy. So there is that. Shh. Anyways, so actually now that I'm looking at it, what happened here? Hey, cat's knocking stuff on the floor. What'd you do? Stop it. Anyways, so this looks kinda I see. It's just the back matches up. I see. But then we should probably have this gone so that this other piece goes through. Which, I mean, we could look at a little bit later. Okay, so that looks good, that looks good. Alright, so now, what are we going to do for the X? So the X, again, let's take a look here on the Trello. X is 48 inches. 48 inches. New space on floor. 48 inches with a 29-inch depth. So 48 inches, half it needs to go on one side, half it needs to go on the other side. So it's 24 inches, and then obviously 29 divided by 2 is 14.5 inches. So 14.5 inches we have to go out. And 14.5 inches, and again also the table will have to, that power bar is going to have to go out that same distance as that 14 inches, and that's where a lot of our weight's going to come into on this gantry. And so that means that also our table should be 14.5 inches wide. So let's go ahead and let's go ahead and duplicate. So what I'm thinking is that, again, we're going to do the 2 gantry. So let's duplicate this. So let's duplicate this, copy, and paste again. Should pop up here. Let's rename this Custom X Gantry. Now what we're going to do is we're going to go in here and we're going to do the exact same thing again. The 2005s and the 20 HGH 20s, but we're going to change how tall this is. So this has to be the 24 inches, right? Yeah, 24 inches. So 24 inches. So it's a short little guy. But remember, one of the things that we're going to lose... Actually, no, we're not going to lose... Actually, yeah, we're going to lose that all the way up to the half. So we're going to lose from here on, and then from here on. So we're going to lose this, which is almost 9 inches. So This is 29 inches. And the Tormach, I think, is 18 inches feed. So 9 inches. We only have 15 inches. Because basically this guy... Actually, no, this... No, this is actually the usable space. So if the spindle's here... So yeah, basically we need 48 inches of clearance on both sides of the table. This is going to go all the way over here, and then this is going to go all the way over here. And all together, plus that 9 inches. So from one side to the other side, we need that clearance, right? But obviously it's not going to travel that full 48. It's only going to stick out this number minus 9. So this number minus 9. So we should get that full distance. So plus 9 inches. So this should be this plus 9 inches. There we go. So now we should get the full 24.5. Or really close. Well, actually, it's going to be that. This one minus 9. So we should get this 24. Should get 24. Which is 48. Yeah. Half of 48. Okay, so let's do this. Let's go ahead and save this. And then this obviously is going to be facing down. But we're going to have something else. We're going to add something else on top. Aluminum or steel. And then there's probably going to be some drilling slots in here after we add a plate on top. And the plate, the idea with the plate is that it's interchangeable. So we're going to bolt the plate on, probably with just here and here. And then we're going to face it on the machine so everything is decked flat, right? For the full travel. Maybe even start out with aluminum, or what we could do is we could do either a slot table, and then instead of losing height, you just bolt on your fixture plate on top of this guy. But I need to be careful that I don't strip these threads out. But if I do, I could drill them out, put a helicoil in them. So not that big of an issue. So let's go ahead and look at this guy. So let's go back to the general layout. Let's drop in the custom X gantry. And let's move it over here. And then let's drop some... Oh, now we need to go on to the Highwind Corporation. And we need to get some custom rails. We need to get some custom length rails again. So products, linear guideways, HGH series. Oops. Configure series, and we're going to do HGH series block. We want a 20 square type, super heavy load. But that's another thing. Do we need a super heavy load? So that is from here to here. It's 9 inches, millimeters, 2 inches. So 9 inches. Can we get both in there? I think it's 92 millimeters. Yeah, we can get them both in there. So we get them both in there, plus some space for the nipples to pop out. So that's perfect, because so this is what we have right here. So I believe they're 92.2 millimeters long total. So 92.2 times 2 is 184, 186, whatever. So we have another 40 millimeters, which is 1.5 inch in between here. So probably the space around here. So that I am happy about. So we are happy about that. So let's look at this. And then what do we need for length? So let's look here. Down to here is 28 inches. What? 28. Wait a second. Oh, this is the wrong one. That's why. I want an X gantry. Oh no, that's right. Oh, did I not save this? That's probably why. Okay, so now it should be 38 inches. Good thing we're going with 20s, because this is getting really, really expensive very, very quickly. 33 inches is 838.2. 838.2. Oh, this is the block. I don't want blocks, I want rails. So 838.2, 838.2. This is to edge, tolerance, blah, 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 standard rail. View. 3D. Download. Upload. Accept user information. Save. There it is. Upload. Close this, go back, close that, keep that up, that's fine. Let's see, HGH, while this is going, HGH 20, HA, high wind. Let's see what we got, price. $1,400 millimeters, 1,200, 1,500. That's way too long. 1,000, 1,200. But yeah, I think we're looking at probably the best option. So let's do another assembly. So let's call this HGH 20 HA and CR assembly medium, so which is X. Okay, so I think that's this one. Yeah. Should be 38 inches long. Or 33, whatever. 33 inches. Okay, and we drop 2 on here. 1. Slider. Oop. Okay, hide joints, drop this next one in, move it, rigid group, flip, slider, and save it. Okay, everything's hidden. Good, good, good. Alright, so now this is the medium, so let's drop a medium in there. Let's move it down, rotate. Good, good. Okay, let's go underneath. That's definitely the end. Sure. I don't think we actually need to capture position, but that's okay. this needs to be rigid. Does not need to be flipped. Oh, I know what I did. I did this middle circle. It's supposed to be this edge. And there we go. Uh-oh. Oh, it's flipped around. Shh. Oops. There we go. And let's do another one. And there we go. So now what is likely going to happen is that this and this are going to be rigidly bound to these here. Basically middle to middle, most likely. So let's joint these. Middle to middle. Shh. Let me open up my door. Oh, Tiger wants to go out. Let me open up my door. Alright, so that looks good. Wait a second. Probably this other way. Okay. There we go. And then booyah. And then nice. Wait, where'd the other one go? The other one's right on top of it. Joints. Come again. Oh, this is wrong. What? Oh. Alright, sorry about that. I had a phone call with one of my clients. Okay, so everything here looks good. So what I do not see here, and what I was looking for there while I was kind of muted, is I do not see a way of... so I grounded this, so now I just move this guy back and forth. So now theoretically I should be able to grab... Okay, that's good. So that works nice. But as you can see, I do not have an option for any sort of like limits. So yeah, I'm gonna have to set limits on those other ones. On these guys itself, but yeah. Oh, actually, this. Oh no, it hits. Gets really close to hitting. Anyways, so yeah, this looks really good. And so if we look at this and we open this up. That's basically as far as it could go. Okay, so let me see. Do I have a pen here? I do. Where's my little maker notebook thing? There it is. So, negative 22.75. And then let's say 0. Okay. Go a little bit farther than that. So 0. Is now it's got to be positive. Okay, so I'll say 0.1. So maximum without looking at the ball screws is 23.75 inches. And now what we have to look at is, so what is sticking out? So it goes 22.75 one side. Okay, so let's see. Does it clear? Did I do any of the math wrong? So 22.75 plus 1 divided by 2. That's 11.875. Not divided by 2. That's the whole travel plus 9 inches, which is 32. Because if we look here, okay, so let's keep these numbers. Then basically what I'm going to do is I'm going to do measurement here. Wait. From here to here is 23. So 23, let's say, or 33. 33. And then let's drive this to negative 22.75. And say OK. Yeah, it's too big. $23.854. So the whole thing is almost like 56. We have 48 to play with. But then again, this is not going to travel all the way. So we could leave some room. So 56. So that's like 8-inch loss. So that's 4-inch on one side, 4-inch on the other side. So we're probably going to need to drop this a little bit. Oops. I don't know why it does this. It's like doubling itself. But that's super cool. So now we have everything there except for obviously the ball screws, and then there's going to be some holes on the top here to do what it needs to do. But everything here looks extremely balanced. So let's look here. 7019 divided by 16. Alright, so we have 438 pounds. I'm going to say we have at least 70 pounds worth of ball screws, so we're at about 500 pounds. Plus this bad boy, the BT40. So let's look at that BT40. BT40 power head. What's the weight of this bad boy? That's it on here. Where does it say? Oh, right here, I think. It doesn't say, but let's see. Oh, so now what do we got? Properties, 8,000 ounces. It's 500 pounds. Plus, like I said, 60 something of ball screws, so we're close to 600 pounds. And then we have motor. We have the motor up here, and then we have like NEMA 24s, and then possibly later on putting gear drives on them. We have table here, vise, the BT40 collet. Power drawbar at some point, all the gantries to hold all this stuff together. I mean, obviously these are the gantries here. I mean, they're basically attached to each other. So eventually I'm going to have to go back and actually put a gantry there. Not how I did it. I mean, there's probably just going to be a couple, like a bracket, and then another bracket that goes down and grabs this ball screw here. From these areas here, most likely. So it goes down, grabs the ball screw, and then there's another ball screw that goes in here. So that guy is what grabs this other. Yeah, that's a good question. What will it grab onto? Grab onto something down here and move it. Anyways, so yeah, it looks really, really good. So yeah, there's going to be a bracket here that just lifts this table up and just keeps everything separate. And so I really, really like this. We're almost at 1,000 ounces. Things are looking really good. and I'm really happy with the build here. Alright, so we are over time by 6 minutes. So thank you for watching episode 12, I believe. And I will see you guys next episode, episode 13. Thanks for watching. Take it easy. Peace.